Okay, today we are looking at Chapter 19, Section B, and we're going to take a closer look at asymptotes. So you're going to want your calculator. First, just as a definition, remember an asymptote is a line that a function gets closer to but never quite reaches. And asymptotes can be vertical or horizontal, and functions can have no asymptotes, one asymptote, or both vertical and horizontal asymptotes. So we're going to start by looking more specifically at horizontal asymptotes. The first thing you want to do is basically you're going to use your calculator to help you understand everything that's going on. But you want to make sure that your calculator window is wide enough, because what we're most interested in is what happens when x approaches infinity and what happens when x approaches negative infinity. So we're really looking at the outsides of our equations, so the far wide ranges of our equations. So what we're going to do is we're going to set our window so that it's pretty large. So we're going to set the window so that we go from negative 100 to x to 100. So go over to your calculator, hit window, and in this case clearly mine's all messed up, so I'm going to hit negative 100, and we're going to go to positive 100. In this case I'm going to count by 20s. The y min, it doesn't really matter at this point, so I'm just going to set it like usual from negative 10 to 10. And our scale will just count by ones. Alright, so now I'm going to go to my y equals, and I'm going to use this equation to start with. So we're going to start with y equals 3 plus 1 over x minus 1. So we type in 3 plus 1 divided by, and then in parentheses I need to do x minus 1. You have to have the parentheses here because you have to designate that you are dividing that whole thing by x minus 1, not just dividing by x and then subtracting 1. Okay, so now we'll graph it and we'll look at our graph. Okay, so if we look at our graph, at the end over here it looks like it's pretty close to a value, and at the end over here it looks like it's pretty close to a value. So what we're actually going to do is we're going to trace. This is the one time when tracing is fine, and we are going to trace to negative x values and then positive x values, and we're going to watch and see what y does at that time. Alright, so we hit trace. There is our cursor. So let's go to the left first. So look at the bottom. What's happening to the y value as x gets more negative? You should be noticing that as x gets more negative, y is getting closer to a certain value, and it looks like it's getting closer and closer and closer to 3. So that tells us that from the left, if we're headed to the left, our asymptote is 3, our horizontal asymptote. Alright, so let's now go the other direction, and we're going to skip over, there we go. As we head to the right, again, what's happening to our y? It's getting closer and closer and closer to 3 as that value gets, as the x value gets bigger and bigger. Okay? So we can be pretty confident that our horizontal asymptote, in this case, is going to be the equation y equals 3. Alright? And from the left, we were approaching the graph from the negative side, from under 3, and from the right we're approaching it from over 3. but it skips over and never touches 3. Okay, so that's a horizontal asymptote. And that's basically all you do. You just look at the graph and you use the trace feature and you estimate what it's going to be. All right? Now let's look at vertical asymptotes. So vertical asymptotes happen basically when there is a fraction and there's a variable in the denominator. And it occurs when the denominator equals 0. So if we go back to our original equation, and we have 3 plus 1 over x minus 1. Just looking at the denominator here, take the denominator, set it equal to 0, and then solve, and you would get x equals positive 1. So in this case, we have a vertical asymptote at positive 1. And asymptotes are shown as lines on the graph. So if we zoom in to our graph, I'm going to use the Z box and down a little bit. Okay, so there's my first corner of the box. Alright, you can actually see it there. So you can see this line is approaching 3 from the bottom. This line is approaching 3 from the top. And both of them, they skip over 1. So you can actually see the asymptote in that case. Alright, so let's practice. We're given a function. We're going to be asked to find the asymptotes, the axes, intercepts, turning points if there are any, the domain and the range, and then sketch it. So in order to find the asymptotes, the first thing I'm going to do is I'm going to graph it. And I'm going to look at the horizontal asymptote, which means I'm going to set my window pretty wide. So we're going to go ahead and type it in, 6 divided by, and I need parentheses for the denominator, x minus 3, close the parentheses, and then subtract 2. So I'm going to set my window to negative 100 to positive 100. I'm going to count by 20s. It doesn't really matter what my y-min and max are, but I'll just make them standard just in case. I want to make sure that I can see everything. And then I graph. Okay, so there's my graph. So now, using the trace feature, we're going to trace to the left. And as I get more and more negative, I am approaching negative 2. I am still approaching negative 2 this time from the top. Okay, so we know our horizontal asymptote is where y equals negative 2. To find the vertical asymptote, now we're going to look at our equation and we're going to take the denominator part, this fraction part, and set it equal to 0. So we have x minus 3 equals 0, so x equals 3. So our vertical asymptote is where x equals 3. So these are the two equations for my asymptotes. And when I graph, the asymptotes are listed as a dotted line. So it's a terrible graph, but 1, 2, 3, and 1, 2. So you would put a dotted line, a dotted vertical line at x equals 3, and a dotted horizontal line at x equals negative 2. Alright? Now at this point I want to find any x and y intercepts. And I just use my normal methods for doing that. So let's actually do the y-intercept first. So we plug in 0 for x. So for the y-int, we would get 6 over negative 3 minus 2. Well, 6 over negative 3 is negative 2 minus 2 equals negative 4. So our y-intercept is down here at negative 4. That basically makes sense. Then to find the x-intercept, remember we use our calculator feature, so we go back to the calculator. We can do second calc, and we want intersect. I'm sorry, no we don't. We want 0 because we want to know where does the function equal 0. And so we need our left bound and right bound thing. So slightly above, slightly below, right in the middle. And it tells us that our x-intercept is 6. Alright, so 1, 2, 3, there's 6. There are no turning points in this graph. We can see that from our calculator because there's no place where it turns. So those are basically the only points that we have to graph. And we can kind of just put little lines on here, make sure that it goes through the intercepts, that it approaches the asymptotes so it doesn't touch them. And now to determine the domain and the range. Domain is how wide it is, and this basically covers infinity except for that one thing, the vertical asymptote. So x is not equal to 3, and as for the range, it basically goes from negative infinity to infinity except for that one spot where it jumps, and it jumps over negative 2, so y is not equal to negative 2. So that's your sketch.